Okay, dear students, today we will discuss about the electromagnetic wave theory. Dear students, we have studied till now, we have studied about the discovery of fundamental particles, different models, and in all these things, we have seen that there is a interaction of matter with radiations. Radiations plays an important role in the structure of atom. So first, we should know what are radiations. Generally, we are taking a very simple radiation, which is light. So first we will understand about the nature of light. Firstly, scientists think that light is having wave nature because it is showing some of the properties of waves like interference, diffraction, etc. And in fact, it was considered to be a transverse wave. Transverse wave means in which the waves movement and particles of waves oscillate in a direction which is perpendicular to each other. For example, I am putting one pebble of stone in a pond of water, and you see the propagation of wave going outward, and water oscillate upward and downward, which means they are perpendicular to each other. But later on, some of the properties of light could not be explained by only considering it to be a transverse wave. So we considered light is a type of electromagnetic radiation. So which about that radiation we will discuss in few segments of this lecture. So we will be dealing with electromagnetic wave theory. Electromagnetic wave theory was put forward by James Clerk Maxwell in 1864. It was given by Clerk Maxwell. Find electromagnetic wave theory. What it states that the energy is emitted from any source, like from heated rod, from filament of a bulb, through which electric current is continuously passed in the form of radiation, is called radiant energy. First point of this theory states that the energy is emitted from any source, whatsoever may be the source. The energy is reducing from any source in the form of continuous wave, in the form of radiation, and that energy is known as radiant energy. And this is your electromagnetic wave theory, which means it is having electric field as well as magnetic field. So in this, the radiations consist of electric field and magnetic field, which are oscillating perpendicular to each other and also to the propagation of wave. See, dear students, suppose this blue line represents the direction of propagation of wave, and this black line represents the electric field, and this red represents the magnetic field. In these, all things are perpendicular to each other, means they are having 90-degree angle in between them, like in 3 axes. Fine. All radiations are associated with electric field and magnetic field, and these electric field and magnetic field are perpendicular to each other and also to the direction of propagation of wave. Fine. Now these radiations do not require any medium for their propagation. You can see sun rays. Energy is continuously coming everywhere. It does not require any medium. Sun rays are going everywhere. Fine. These rays do not require any medium for their propagation, and these rays are your electromagnetic radiations. Fine. Now, there are some of the characteristics of electromagnetic waves. It's a small topic and the easy one. Characteristics of electromagnetic wave. EM wave. Characteristics of EM wave. Fine. EM means electromagnetic wave. See, there are some important characteristics of EM wave, which is wavelength, frequency, amplitude, wave number, fine, which characterize the electromagnetic wave. We will learn all these terms one by one. First one is your wavelength. Dear students, if we are considered it as a wave and it is moving like this, suppose radiation is moving like this, these upper positions are, suppose it is crest, it is trough. Imagine the movement of water waves in sea water. Fine, imagine. Now, what is wavelength? First characteristic is wavelength. It is represented by lambda. Represented by lambda, which is equal to the distance between two consecutive crests or two consecutive trough. Wavelength is defined as the distance between any two consecutive crests or any two consecutive trough is your wavelength of a particular wave. Dear students, its SI unit is meter. Fine. SI unit is meter, represented by wavelength, represented by lambda. Fine. Second is your amplitude. Amplitude means from a particular point, from any position, how much a particular wave can maximum displace. Suppose this is the distance. From this point, the maximum displacement of this point is up to this point. So this is the amplitude of wave. It can be in crest or it can be in trough. The maximum distance displaced by a particular wave from a particular point, or you can say that it is the height of the crest or height of or the depth of trough. It is represented by A. Amplitude is represented by A, and its unit are same as that of length. Fine. Now, third quantity is frequency. Third characteristic is your frequency. Frequency means the number of waves passing through a point in 1 second. My dear students, suppose this is the point. For example, I am taking this point. From this point in 1 second, how many waves are passing? For example, this is the point. This is the point, and from this point, how many waves are passing in 1 second is the frequency. Its units are hertz, which is equal to 1 cycle per second. Fine. Frequency's unit is hertz, which is equal to 1 cycle per second. Last is your second last characteristic is your wave number. Wave number. It is the inverse of wavelength, which means the number of waves present per centimeter length. What is the physical interpretation of wave number? It means in 1 centimeter length, how many waves are present? Or evidently, it is the reciprocal of wavelength. Wave number is represented by nu bar. It is equal to 1 over lambda, or lambda is equal to 1 over wave number. 5. Frequency is represented by nu. Amplitude is represented by A. Wavelength is represented by lambda. Last characteristic is your velocity. Velocity is same. What? Velocity of a wave is defined as the linear distance traveled by a wave in 1 second. Velocity is distance over time. How much linear distance is traveled by a wave in 1 second? It is represented by C, and its units are meter per second. Represented by C, and units are meter per second. Dear students, I have discussed about electromagnetic wave theory. Electromagnetic waves means the waves, the radiations, which is having both magnetic field and electric field, and also they are perpendicular to each other, and they are also perpendicular to the direction of propagation of wave. Fine. These rays do not require any medium for their propagation. They can travel anywhere. Fine. Now, some of the characteristics of electromagnetic wave. First one was wavelength. Wavelength is the minimum distance between two consecutive crests or two consecutive trough. Next, wavelength is represented by lambda. Its units are meter, SI unit meter. Now, wave number means the number of waves present per centimeter length. Its unit are inverse of wave length, that is meter inverse. It is represented by nu bar, which is equal to 1 over lambda. Next, amplitude. Amplitude is represented by A, which is equal to the linear, which is equal to the height of crest or depth of trough. Now, velocity. Velocity is the distance traveled by a wave per second. And frequency. Frequency is the number of waves passing through a particular point in 1 second. Till now, is there any doubt? Please let me know. Velocity, frequency, and wavelength. Dear students, in vacuum, the speed of or the velocity of all the radiations is same. In vacuum, the speed of radiation is 3 into 10 raised to power 8 meter per second. This constant value is helpful in giving the relationship between C, mu, and lambda. And according to this, C is equal to nu lambda, where C is your speed of light, nu is your frequency, and lambda is your wavelength. It's the important relationship. Fine. C is equal to mu lambda. Within 5 minutes, I will be discussing the numericals based on it. First, I will tell you a little bit about electromagnetic spectrum. The different types of electromagnetic radiations differ only in their wavelength, and hence their frequency will be different, because this term is constant. When one thing is changing, another thing should automatically change to make it constant. So, Kunal, why you are laughing? Concentrate on the board. When the different type of electromagnetic radiations differ only in the terms of wavelength and hence frequency. So when we arranged all these electromagnetic radiations in order of their increasing wavelength or decreasing frequency, we are arranging the radiations in the form of increasing wavelength or decreasing frequency. The continuous band we obtained is your electromagnetic spectrum. Fine. Like the cosmic rays is having the least wavelength and radio waves is having the maximum wavelength. Fine. So the arrangement of electromagnetic radiations in order of their increasing wavelength or decreasing frequency is your electromagnetic spectrum. That's all about your electromagnetic wave theory. Now we will discuss some questions of NCERT based on the same topic. Take your NCERT books and practice notebooks with you and solve the questions with me. Fine? So first in-text question of NCERT based on electromagnetic wave theory. Calculate the wave number. You have to calculate the wave number and frequency. Fine? Of yellow light, yellow radiation having wavelength. Wavelength is equal to 5000 angstrom. Fine. You have to calculate the wave number and frequency. Wavelength is equal to 5000 angstrom. Dear, 1 angstrom is equal to 1 angstrom is equal to 10 raised to power minus 10 meter. So first convert it into meter. Lambda is 5000 into 10 raised to power minus 10 meter. And we have just seen the relationship between these two terms are this. C is equal to 3 into 10 raised to power 8. It is fixed. It is given to us. What is the value? 5000 into 10 raised to power minus 10 is equal to your frequency. Fine. Or what is your wave number? Solve it. What is your wave number? Wave number is equal to 1 over wavelength. So wavelength is what? How much? 1 over 5000 into 10 raised to power minus 10. Whatsoever may be the answer, write units also per meter and here hertz. Simple question. Is there any doubt in this question? Please let me know. The Vivid Bharati station of All India Radio Delhi broadcast at a frequency of 1368 kilohertz. Frequency is given to us. And you have to calculate the wavelength of the electromagnetic radiation emitted by the transmitter. Okay, first, do not forget to convert the frequency kilohertz into hertz. And 1 kilohertz is equal to 10 raised to power 3 cycle per second. So, again, the same formula will be used. C is equal to nu lambda. Now, this thing is given to us, its value is constant. 3 into 10 raised to power 8. And it is how much? 1368 into 10 raised to power minus 3. Because 1 hertz is equal to, 10 raised to power 3. And it is equal to your wavelength. Right? Units also. Fine. Now, third question of NCERT in text based on the same topic. The wavelength range of visible spectrum extends from violet 400 nanometer to red 750 nanometer. Express the wavelength in frequencies, and 1 nanometer is equal to 10 raised to power minus 9 meter. I repeat the question. The wavelength range is given to us. That is 400 nanometer to 700 nanometer. You have to convert these wavelengths in terms of frequency. So first wavelength, that is of violet radiation, is 400 nanometer, which means 400 into 10 raised to power minus 9 meter. For red radiation, it is 700 nanometer. It is given to us. Fine. You have to convert in terms of frequency. So calculate frequency for all these radiations. C is equal to nu lambda. So 3 into 10 raised to power 8 over this. And again 300 into, 3 into 10 raised to power 8 into 700 into 10 raised to power minus 9. Solve it and send me the answer fast. Solve these things. We just have to write the range. It comes out to be, first one comes out to be, second is 750. It is 750. Solve it fast and send me the answer. I will see who is sending me the answer fast. Solve. Very good. Very good. The answer for the first one is 7.5 into 10 raised to power 14 hertz. Fine. And for second is 4.0 into 10 raised to power 14 hertz. So you just have to write this range. So how much is the range? It will be from this range to this range. 4.0 into 10 raised to power 14 to 7.5 into 10 raised to power 14 hertz or cycle per second. I hope it is clear to you. Still any doubt, please let me know.